Hey everybody, this is Kaspar and welcome to a new episode of Building Platforms with Kaspar, this time with a high security edition, something that I've been looking forward to a lot. We have been focusing and working so much with very secure aware industries like banking, insurances, government, defense. And what we've heard continuously is that what they need differs a lot from everybody else. And if you are practically rolling out platforms with them, you'll see it and you'll notice this immediately. Now, in this episode, I want to walk you through the specific requirements that these situations and estates bring with them. I want to look at how to architect and use the idea of platform engineering and to be very specific, platform orchestration and the idea of abstraction and standardization brings to high security estates. Deployment to darkness scenarios are scenarios where the developer is developing, but the actual running code can run across several different destinations and sometimes environments, and sometimes the developer doesn't even know how the configurations of the database in production in the data center in New York will be in the end. We still need to have a chain where the developer can specify that they need a database and a system needs to orchestrate how all of those configurations for the different destinations are created. So now let's start actually understanding the specific requirements of security-aware industries and estates, and then understand how to architect that using a platform orchestrator. And then I want to give you a demo of some of the common use cases so you can experience this firsthand. Are you ready? Let's go. Okay, so what makes high security environments so special if it comes to deployment, architectural setups, etc.? Well, if you look at most of the estates that we're seeing in banking, for instance, you can see that deployment complexity really explodes. And some people say, well, that's because, they like to overcomplicate things. It's much more because of the compliance and regulatory requirements that these environments face. You can't just deploy to the cloud, right? You need air-gapped networks, specific data centers, compliance zones, etc. And that means if you break that down on an environment by environment level, you need to have different security policies, network configurations. You need to meet those regulatory requirements. So what I want to do now is that I want to look at such an estate that I believe is representative for a lot of the setups that I've seen in banking. Fantastic. So now let's assume we have a banking application called the payments ledger, and this payments ledger processes financial transactions, account data, really things that are, you don't want that to fall in the wrong hands. Let's put it like this. So I'll just run a CLI command here against the orchestration that we've set up, and I'll explain how all of that works in a second. Pull the different environments that we have to serve with this for this application. Okay, so what do we have? We have the dev environment of type development. So this is isolated development network with mock data. This is where my developers would typically actually run their dev workloads. And we can see here a couple of things we'll cover later, right? Like the runner, like how is the orchestrator actually executing this on the payments ledger. And this is something that we're running in a shared Kubernetes cluster in GKE here. And then we have a QA environment that is, where do we have our QA environment? Yeah, here. That is of type staging, so it's staging-like. And it is something that we're using to mirror production data and production security grades so that all the tests that we are running are representative on how they would then run in production. Then we have prod 1. Where is this? Prod 1 in a data center. That's the primary production data center in New York, and it's strictly PCI compliant. That is a standard example that we have here in the banking world, where you need to have to meet regulatory requirements by zone and by country you're serving. Then we have prod DC2. That is another data center in London, with, again, different data residency laws. And then we have a DR cloud production environment. That is a disaster recovery site that is air-gapped, and again, for regulatory requirements, run with a different infrastructure provider. In this case, we are running this one again in GCP. You can do the math. Those are a lot of files to maintain. Now, developers need separate manifests that represent all of those environments. They need different application configurations. They need different deployment scripts. They will need help with all of those things to manage. If they need any change on the target, they will need to talk to somebody. That all leads to configuration drift between those environments, and that in turn leads to production failure, outages, security incidences. It also means that compliance audits become nightmares. Well, let's say you need to prove that dev matches prod and who has deployed where and what changes were made to what configs. And, if you've ever been part of such an audit, you know how troubling that can be. And then for things like disaster recovery, testing requires a completely different deployment procedure. You really need to try to mimic the behavior of the different data centers. And if you then need something like a new environment, let's assume you have a situation where, many developers are working against dev, but dev is currently, closed because other colleagues are using it, then you have no other choice but either to wait or request a new environment. But a new environment, again, needs custom configurations and setups and all these things. So if we really boil this down to the key pain point here, the same application code, the same artifact needs essentially 5 different ways to deploy it, one for each environment. And that is where complexity scales, where it's hard to standardize, it's hard to maintain. You have these unstructured silos. It's where security actually becomes a problem in the governance. Maintenance hell breaks loose. In general, things are hard to maintain. That puts an incredible pressure on the operation teams, on the security teams, and it obviously hinders developers from doing their job and working productively. So let's try to understand how you can solve that enigma through intelligent use of platform orchestration. So what's the solution? And how do we actually architect that? And how does platform orchestration help us to solve all of those problems? And that is actually pretty straightforward. We're seeing that here in this diagram. The idea is that you put a rules engine essentially between the developers that are just abstracting or that just want to deploy into the different environments, and the actual infrastructure rules, so to speak. So if we want to boil it down to one, concept, rather than having to deal with many, many configurations, the developers just get a single configuration, essentially the manifest file that we're seeing up here. Now let's actually have a look at such a manifest file that you could use for our payment ledger application right here. And you can see that this is essentially an abstract description of the resources and the workloads that this thing requires. So you can see that this is using sort of a shared resource, in this case of a type Postgres, and that we have the workload called payments ledger service, and then there are a couple environment variables, and that we have resources like a namespace and a Kubernetes service account. So this is something that we're using here, Kubernetes as the compute orchestration, essentially. The fascinating thing that you're seeing here in this manifest file is that it does not contain any environment-specific configurations. Right? So you don't see a localization to dev or the different prod environments. We're just, as developers, describing what are the different things my payment ledger service needs that hold true across all environments. Looking back at this thing here, the developers really just need to use that manifest on top. It's essentially one manifest that specifies things that matter to the developers across all environments. Because in this world, especially in banking, it doesn't matter so much how the actual, compute is configured on the data center in New York, right? What matters is that in general, the developers know that their workload needs a Postgres database and specific other components. All right. And then if we look here, the manifest gets sent to the orchestrator, the platform orchestrator. And that orchestrator is, you can think of this like a rules engine that now takes that manifest and essentially localizes the configs to fit exactly the regulatory compliance needs of all of the different environments. And the orchestrator itself, that's really important, is the version 2 of the Humanitech Platform Orchestrator, which is compute agnostic and which is now running on the network of the bank. So it's not the SaaS hosted version, it's actually running in the data center, in the cloud account, and it's self-hosted. And that is absolutely vital in this case because you do not want to have any network traffic in or out. You could think about this from a security perspective. Those orchestration systems can be the perfect attack vectors for supply chain attacks. And so here, by actually hosting the orchestrator on their own premises, on their own clouds, we are making sure that this is 100% contained and there is, again, no network traffic. Then the orchestrator is connecting to the different environments and clouds and data centers through secure VPN tunnels. And what it's doing now, it's taking that manifest, it's analyzing what are the default configs provided by the platform, operations and infra teams, it's generating the configurations, and it's then sending them to DC1, DC2, to US Central 1, to all of the different things, to the dev QA and production environments right there. Let's actually look at this from a different perspective and go even more into detail. If we look at this diagram here, you really have the orchestrator in the middle, and it shows really well that you have two persona groups that can focus on different things and really do not have to even talk to each other. You have the developers here on the upper right-hand side in their CI/CD and IDE stream that can request a deployment, that can indicate that they need the Postgres database. They just send that request to the orchestrator, or they can say, hey, I'm now deploying to DC1 in New York, and the orchestrator will create all of the stuff, provide the outputs to the CI/CD system, will have the images or the artifacts pushed to the artifact registry, and then this can be combined and deployed into the target infrastructure. Now, note that here on the left-hand side, the platform engineers are the ones configuring the orchestrator, right? So they are the ones that are configuring the, Terraform modules that now actually define how the Kubernetes namespace is configured in the data center in New York. And they are the ones that are actually defining what the compliance and regulatory rules are. And the orchestrator, again, is sort of the rules engine that combines these things and makes sure that every time we're deploying, we have 100% standardized and structured configs for exactly the target environment that we're going into. And then obviously you can use the orchestrator has a very powerful backend API to observe and analyze all of that, wire these things into Grafana and portals and all of that, and I can show that quick glance at that later as well. All right, so this is the UI of the platform orchestrator that is running, as I said, on our data center and or our cloud account. And here I can see the payments ledger, and I can see all of the different environments that we looked at previously: Dev, DR Cloud, Prod TC1, Prod TC2, and QA. And before I show you how developers would interact with this and apply changes, let's actually go into one of those environments, and we can see that there's a resource graph running. And the resource graph is a real-time representation of what you have running in the different environments. So here in the dev environment, which is I think running in GCP, we can actually see that we have a workload, we have a service account, we have the namespace, we have the Postgres database. That's the materialized thing from the manifest file that I showed you earlier. So the manifest file is coming, and then the orchestrator is actually making sure that those infrastructure components run in the target environments. We can look at the Postgres. We can see that this is, for instance, a shared Postgres, and that we have all sorts of metadata, and we can extend the metadata model from here. Okay, now with that, let's actually start the demo and assume we're now a developer. And we're assuming we're a developer who wants to add an S3 bucket across those different environments and wants to do that without having to raise a ticket in ServiceNow or wait for other teams, really just by staying where they are. And where they are is usually in their IDE in code. So let me show you that. Cool. So let's say I'm the developer and now I want to add an S3 bucket. And I first just want to add this to dev. So in my previous world, I would have gone to an operations team and asked them, and I would repeat this across the different environments, and security would need to look at this, etc. But in this world, I really just have to go to the manifest and I'll say, give me document storage of type S3 where class is default. Now, class is something that allows me to be a little more granular. So my infrastructure team could say, there are different options for S3 buckets and object storage, private, public, small, whatever. In this case, I'll just offer class default. And then I probably also want to have a couple environment variables here that help my workload connect to this. And I'll add the document storage bucket, the name, and I will add the region. And with that, I will save this. And I will go to my terminal and I will deploy this to dev. Yeah, so what does this command tell us? This is the humanitarian org. Deploy the payments ledger to the development environment, and this is the path to the manifest. And off we go. And then this will actually take this, it will see whether there are changes, will detect those changes, and it will send that to the Platform Orchestrator that's running self-hosted in our network. And the orchestrator will then say, okay, well, there's S3 bucket. Where's this going? Dev, what are the global rules, compliance, things, infrastructure as code for that specific target? Let's make sure we get the exact right configuration of object storage, wired, spun up, and wired to that resource, to that workload. And now let's say I'm a developer and I want to add an S3 bucket to my payments ledger service. And I want to do this across the different environments. So in my previous world, I would have gone to the operation team or filed a ticket, and they would have done that environment by environment. And then there would be a security review. And a couple of days later, I would have my S3 bucket. Now in this world, I can literally just go into the manifest file here. And in the shared part, I can say, give me document storage of type S. And it's really as simple. So this one just tells me what type I'm requesting and helps the orchestrator match to the provided rules by the platform team. And I can also be more granular as an infrastructure team and say you can have small, medium, large buckets, you can have private, public, whatever. But in this case, we're just going to use the default one. And then we are also going to add a couple variables, and this will be bucket name. And then I think we'll just keep regions here, and that allows the workload to connect to that bucket. And then we're going to save this, and I'm going to head over here to my terminal. And I'll say with this command, take the payments ledger and deploy this to dev and use the changes on the manifest. And this will now read the changes of the manifest, and it will call the orchestrator in the back, and it will say, hey, orchestrator, add an S3 bucket. The orchestrator will figure out what are the rules and the configurations that the infrastructure team wants for S3 buckets in development. It will spin up that S3 bucket. 16 seconds later, we're done, and we can look at the resource graph to verify the changes. And if we now navigate to the dev environment, we should see the S3 bucket, and yeah, we can see it's added. So this is, just the representation of the actual S3 bucket that was created in that dev environment. And we can see the variables are wired and binding, and I can look at the metadata, etc. So that all looks very good. Now let's repeat the same thing for QA. And now if I want to do this for QA, I take the exact same manifest file here, document storage, S3, my variables. And now I just run the command, and the only change is that I now send this to the QA environment, and off we go. And this will now again send this to the orchestration, and the orchestrator will crunch this and figure out how we want to have the S3 bucket configured in the QA environment, spin this up, wire this to the workload, and after 18 seconds, we're done. Yeah, and if we now navigate to the QA environment, we should see the S3 bucket. And here we go. Here's the S3 bucket, which with all its metadata for the QA environment. So the workload is now in QA is now able to connect to the S3 bucket, in this case, a shared resource. Good. So that worked out well. We have the one manifest, and every time we just say, give me the deploy this to dev or QA, the orchestrator is able to localize all the stuff to meet these requirements. How does the orchestrator know how to create and configure the S3 bucket? Well, that's something that we configure as code from the platform engineering and the infrastructure side. And then we match this. So a platform engineer can make resource types available. We have the different types here, resources of type buckets, DNS, namespaces, lambdas. You can really create whatever you want on your menu, GPU compute. So that's very, very flexible. And then in the module section, you really configure when to use what in what situation. You, for instance, say, hey, if somebody deploys to a development environment, I want you to utilize one shared Kubernetes cluster. By the way, here is the source to the infrastructure as code. And this way, the orchestrator knows when to use what resource, how to inject the variables, etc. So very, very structured and flexible setup and very scalable, and everything managed as code. So I'm showing you this in the user interface now, but everything is backed as code. I'm a big believer in everything should be code. The platform itself should be code too. There are now, because of this API nature of the orchestrator, a whole lot of things that makes the life for platform engineers significantly easier. For instance, by using the Platform Orchestrator API, you are able to detect drift. You can wire this to your observability tooling. We're seeing a drift detection dashboard here in Grafana, which would flag that there is an asynchronicity between the actual running infrastructure and the configuration. Let's assume somebody somehow sneaked their way into your data center in New York and changed some configs, and the actual policy compliant configuration in your repositories differ from the running system, then this can be flagged by the orchestration, and we can then go in. The resource graph will show, hey, drift detected, do you want to remediate? And you can immediately take actions to do that remediation. Or let's say in a different example, you have detected anomalies in your databases, or there are error messages firing off, and you want to resolve an incident by rolling back. Point rollbacks are the orchestrators able to do point rollbacks that include the application and the infrastructure configuration as once. That is obviously super powerful. You could pull all sorts of other metrics from the API. You can spin up and down ephemeral environments. So there are really so many things that are possible because that nature of the orchestration encompassing application and infrastructure in one consolidated model. Okay, so what have we demonstrated today? Well, we looked at a real banking challenge. We have the payments ledger across 5 different environments, hybrid infrastructure with cloud, dev, QA, and DR, and then on-premises with production across 2 different regulatory zones, complex compliance requirements, and all of that. And the solution that the orchestrator gives you is that you have one manifest, but you have 5 different infrastructures. And we added that S3 bucket to show actually how, just one line of configs or a couple line of configs allow you to deploy into dev QA with the same file for the developers, but all the complexity is shielded. What are the key benefits of this? Well, first, speed and efficiency, right? You're able to serve all the different environments in literal minutes. Think about how much time that would have taken to make sure that the S3 bucket is secured and available in all the different regions. We then have a single source of truth. We eliminate configuration drift. I showed you how you can then actually do drift remediation, and it means that developers can focus on business logic rather than having to wait for tickets. It obviously also leads to cost reduction, infrastructure coordination, siloed teams that have to talk to each other, reduction of deployment failures, production incidents, and it allows you to really scale your development velocity without having to scale your operational overhead. Then compliance and governance, right? Consistent policy enforcement. The fact that the orchestrator is running on premises allows you to really keep all the traffic within your controlled networks. You have an audit trail for everything that's happening across all the different entities, and all of that mitigates your risk. You have no configuration drift, or if somebody ever manages to get in your data centers, we're able to remediate this. We can do automated compliance checks before production, and you have very highly standardized patterns. So if we really want to boil this down to one line, same application definition, but then the platform orchestration handles the high batch complexity, whether it's a cloud development or on-premise production for disaster recovery. Is really deploy once, run everywhere, and stay compliant. Now, you can test, obviously, the SaaS version by heading over to humanitech.com and trying our 10 minutes sandbox. You don't even need your own cloud accounts. That's super fast. If you want to use the on-premise version, please do get in touch with us. We're happy to help you set this up, test, and then take it from there. And with that, happy platforming. See you soon.